Hello friends, myself Subhash Nagarse from Sri Digambar Jain Gurukul High School, Solapur. I shall welcome to all of you in this 10th Standard Science and Technology part 1st. The question bank that we are going to discuss is prepared by SCRT. Today we will discuss on chapter number 5 and 6 and the type of the question is follow the following questions. Let us start with that. Question number 2b, solve the following questions, 2 mark each. In the previous videos, we have been discussed 27 questions. Now we'll start with this 28th one. Draw a neat and able diagram of Hope's apparatus. The Hope's apparatus is like this, the diagram for this one, wherein 4 things have been shown. Freezing mixture, this one, freezing mixture which is in this container, and thermometer T1 which is at 4 degrees Celsius and thermometer T2 which is at 0 degree Celsius. Next question, name the following diagram appropriately. The same Hope's apparatus has been given over here, and 4 blocks you could see, and let us name them as freezing mixture in this container, this one, thermometer T2 and thermometer T1. Observe the following diagram and write the answers to the questions given below. You could see here I have one of the graph which is shown a specific volume on the y-axis and temperature in the degree Celsius on the x-axis. The nature of the curve has been shown over here. The questions are, which process does the graph represent? The answer will be, the graph represents the anomalous behavior of water. What is the range of temperature responsible for the behavior? The range of temperature responsible for the behavior of this is 0 degree Celsius to 4 degree Celsius. How much heat will be required to raise the temperature of 5 kg of water from 20 degree Celsius to 100 degree Celsius? Mass m is equal to 5 kg. Specific heat of water C is equal to 1 kilocalorie per kg degree Celsius. Change in temperature, that is delta T is equal to 100 minus 20, 80 degree Celsius. We have to find out the heat energy Q. The formula used is Q is equal to mc delta T. According to the principle of heat exchange, energy supplied to water is equal to energy gained by the water. From the formula, Q is equal to, we will get this mct. So 5 into 1 into 80, that is 400 kilocalorie. So the heat energy necessary to raise the temperature of the water is 400 kilocalorie. Next question is, find the amount of heat needed to raise the temperature of a silver container of mass 100 gram by 10 degrees Celsius. Here the C is 0.056 calorie per gram degree Celsius. Given things are, mass m is equal to 100 gram, change in temperature delta T is 10 degrees Celsius, specific heat of the silver is 0.056 calorie per gram degree Celsius. Here we have to find out the heat energy. Formula used is Q is equal to mc delta T. According to the principle of heat exchange, energy supplied to the silver container is equal to energy gained by the silver container. So from this formula, we can write Q is equal to 100 into 0.056 into 10. The multiplication of this gives rise to 56 calories. So heat energy needed to raise the temperature of the silver container is 56 calorie. 33. If water of mass 60 gram and temperature of 60 degrees Celsius is mixed with water of mass 60 gram and temperature 40 degrees Celsius, what will be the maximum temperature of the mixture? Friends, here let the maximum common temperature of the mixture be 80 degrees Celsius. According to the principle of heat exchange, we can write that the heat lost by the hot water is equal to heat gained by the cold water. So m hot C T hot minus T is equal to m cold into C into bracket T minus T cold. So given things are here, m hot is equal to m cold is equal to 60 gram. Therefore T is equal to T hot plus T cold by 2. 60 plus 40 upon 2, that is 50 degrees Celsius. So this maximum temperature of the mixture will be 50 degrees Celsius. Next 34. Find the amount of needed To raise the temperature of piece of iron of mass 500 gram by 20 degrees Celsius, here C is 0.110 calorie per gram degree Celsius. Given mass m is equal to 500 gram, change in temperature delta T is 20 degree Celsius. Specific heat of this iron C is equal to 0.110 calorie per gram degree Celsius. We have to find out the heat energy Q. So Q is equal to mc delta T is the formula. According to the principle of heat exchange, energy supplied to iron piece is equal to energy gained by iron piece. So from this formula, Q is equal to 500 into 0.110 into 20, which will be 1100 calories. So heat energy needed to raise the temperature of piece of iron is 1100 calories. That is 1100. 35. If the absolute refractive index of water is 1.36, find the speed of light in water. Speed of light in vacuum is equal to 3 into 10 to the power 8 meter per second. Here given things are absolute refractive index of the water n is equal to 1.36 and velocity of light in vacuum v1 is equal to 3 into 10 to the power 8 meter per second, and you have to find out the velocity of light in water v2. Formula is refractive index n is equal to v1 upon v2. So from this formula we can calculate v2 is equal to v1 upon n. So 3 into 10 to the power 8 upon 1.36. After calculating this one, you will be getting v2 is equal to 2.21 into 10 to the power 8 meter per second. So you can write the velocity of light in water is 2.21 into 10 to the power 8 meter per second. Next, 36. If the absolute refractive index of the glass and water are 3 by 2 and 4 by 3 respectively, what is the refractive index of glass with respect to water? Here, if V1 is the velocity of light in vacuum and V2 is the velocity of light in glass and V3 is the velocity of light in water, then absolute refractive index of glass, that is the refractive index of glass with respect to vacuum, is equal to Ng is equal to V1 upon V2 3 by 2. Equation 1. Absolute refractive index of water, that is refractive index of water with respect to vacuum, Nw is equal to V1 upon V3 4 upon 3. Equation 2. Refractive index of glass with respect to water is G, Nw is equal to V3 upon V2, and you can put the values V1 upon V2 into V3 upon V1. This equation is changed in this way, means multiplying the numerator and denominator of right hand side by V1. Therefore, you can write G and W is equal to the value will substitute V1 upon V2 and V3 upon V1, 3 by 2 into 3 by 4. So, we will get that is G and W is equal to 9 upon 8. Solve the following example. Speed in first medium V1 is equal to 3 into 10 to the power 8 meter per second. Speed in the second medium V2 is equal to 2 into 10 to the power 8 meter per second. Then 2 and 1 is equal to what? Given speed of light in the first media V1 is equal to 3 into 10 to the power 8 meter per second. Speed of light in the second media V2 is equal to 2 into 10 to the power 8 meter per second. We have to find out the refractive index of the second media with respect to the first media, that is 2n1. Formula is 2n1 which is equal to V1 upon V2. So calculation will get 2n1 is equal to 3 into 10 to the power 8 upon 2 into 10 to the power 8, which will be 1.5. So 2n1 is 1.5. So the refractive index of the second media with respect to first media, that is 2n1 is 1.5. Draw a neat label diagram for the dispersion of light. The figure is like this. This is a prism wherein an incident light, white light, sunlight is there on this surface PQ. AB is the incident and it get dispersed into constituent colors, because white light consists of 7 colors that start from red, orange, yellow, green, blue, indigo and violet. In short, you can write Fibgor, Fibgyor. It is called as spectrum of light. White light get into its constituent colors. Observe the given figure and name the following. This is the figure. A glass slab is there. AB is the incident light. Then this N and M at these places normals are drawn. In the absence of this glass slab, the light may pass through with dotted line shown. Here with red color NM is refracted. Again one more refraction takes place over here. CD is the emergent ray. So friends, here what is this ray AB? Ray AB is called as the incident ray. This NM, ray NM is called as refracted ray. Ray MD or you may CD, it is nothing but an emergent ray, and angle R that is shown here is the angle of refraction. What is the refraction of light? Explain with the help of example. Friends, refraction of light, the phenomenon of a change in the direction of the propagation of light when it passes obliquely from the transparent media to another is called refraction of light. The coin disappears in a vessel as it is seen from a specific location, but as soon as the water is poured into the vessel to a certain level, the coin appears. This is because light rays coming from the coin emerge out of the water and change their direction due to the refraction of light. What is meant by dispersion of light? When light passes through a prism, it is separated into distinct color components. This is referred to as a light of dispersion. A white light beam is divided into 7 hues colored by prism: violet, indigo, blue, green, yellow, orange and red. State the laws of refraction. Here, first laws of refraction. First point, the incident ray, the refracted ray and the normal to the interface of two media at the point of incidence will lie in the same plane. The ratio of the sine of the angle of incidence to the sine of the angle of refraction is constant. For the light of a given color and for the given pair of media, this law is also known as Snell's law of refraction. So n is equal to sine A upon sine R. Here n is small letter also you can use. This constant is called the refractive index of the second media with respect to the first one. If the speed of light in a media is 1.5 to 10 to the power 8 meter per second, what is the absolute refractive index of the medium? Absolute refractive index of the media mu is equal to speed of light in air upon speed of light in the media. So mu is equal to 3 into 10 to the power 8 divided by 1.5 to 10 to the power 8, that gives you 2. So mu is equal to 2. The refractive index, absolute refractive index is 2. So friends, I think you understood all the problems. In the next video, we will discuss the remaining, solve the following questions from the remaining topics. Thank you for watching this video. We will meet soon with the next video. Till that, bye.